Assalamualaikum. My name is Khairul Zahir bin Zaim. My course code and class is AAP1163D, and my metric code is 2019258258. Okay. The introduction of the buildings that I want to say here is we provide a 3-level underground parking lot for the purpose 7-story private hospital with 777 beds in Perak Tengah to develop a suitable building survey system. I would like to propose the water supply system that we use for the buildings is indirect cool water supply system. So the cool water supply systems has less wear on pipe materials than direct supply because of less pressure on them. The indirect power supply is also quite quiet, and some storage space can be reserved to prevent the main cool water supply from being cut. And the benefits that we get for the indirect cool water supply system is it is impose less pressure on distribution network, as rising main is not connected to all fixtures directly. And for the other benefits that we got is the water flow that enters building slowly, so the pressure does not damage the equipment, and the presence of storage tank as the water supply will not be disrupted in event of failure at the main water supply source. The next system that we use for the buildings is central hot water system. So for buildings such as hospitals, the central hot water system is almost the only system we use because it can provide sufficient reserve for heavy workloads and can avoid maintaining a large number of small units. This heat usually comes from a central plant that meets all of heating requirements. Both cool and hot water supply system are suitable for indirect water system too. The benefit for the central hot water system is the water transfer energy at 4 times the rate of air, making warm water central heating system more efficient than warm air system. And rather than that, it is more economical. The initial setup costs are paid back by the long-term cost benefits, and the system are visually quiet and so on. The system are fully programmable, and they can be thermostatically controlled or turned off in rooms that are not being used.
Lecturer TS Muhammad Naim Mahyudin, name given Muhammad Abdul Hasan, and I will talk about sewage treatment. Type for sewage treatment. A suitable type for sewage treatment is that I will be proposing for 7-story of 777 bedded private hospital which we built in Perak Tengah, STP. Moreover, there are many types of sewage treatment, and one of it is septic tank, which will seal around or rectangular container which is used to break down the sewage so that it becomes effluent. Operational process for sewage treatment. First is preliminary stage of pre-treatment. Second is primary treatment stage, and third is secondary treatment stage. This is the figure for tertiary treatment stage. This is the process. The sewage treatment plan steps. Step 1. Screening and pumping. Step 2, grid removal. Step 3, primary settling. Step 4, aeration or activated sludge. Step 5, secondary settling. Step 6, filtration. Step 7, disinfection. Step 8, oxygen uptake. Is like this. Benefits or advantage for sewage treatment plant, or known as STP, is that STP is proven technology which offers reliable performance at all times. Also, sewage treatment plant preserve natural environment against pollution. STP meet the standards for emission of pollutants set by the government and avoid heavy penalty. Simple and easy installation, low operation and maintenance of plant. Installation of STP reduce risk held in the environment. Related specification or regulation. There are 7. First is BS ISO 25780 in 2011. Second, BSEN ISO 1452 to 2009. Third is BS ISO 24511 at 2007. Fourth is BSEN 12201 to 2011 plus A1 2013, BSA 595 2013, BSEN 12201 to 3 2011 plus A1 2012, and lastly is B 50541/1. This is all the code for related specification or regulation.
Hello, my name is Muhammad Fahmi. I will present about mechanical ventilation system. The type of mechanical ventilation system is leak delivery mechanism, a model of mechanical ventilation, leak exhalation. We go to operation process. A mechanical ventilator is a system that under a patient to breathe when they are undergoing surgery or because of a critical condition. They cannot breathe on their own. The patient has a hollow tube connected to the ventilator which goes into the mouth and down into their main waist or trachea until they improve enough to breathe on their own. Then stay on the ventilator. The minimum breathing work. A mechanical ventilator is used before patient delivered enough to no longer need it. The system makes sure that enough oxygen is obtained by the body and that carbon dioxide is eliminated. This is important when normal breathing is prevented by some illness. We go about advances. There is no need for the patient to work as hard to breathe their respiratory muscle rise. The patient is given time to recover in hope of returning to normal breathing. It helps the patient to receive enough oxygen and reduce carbon dioxide. Maintain healthy weight and avoid respiration injuries. B22 relate specification or regulation. F3 suction and aerosolized gas bronchoscopy. Suction, this is a process where a catcher is inserted into the breathing tube to have extra saturation. This is for CO2 This procedure may cause the setting to cold or gas, and monitoring may be uncomfortable. Circulation can also produce a blow-in from the subsystem, and it is necessary to note that to keep the airway free of circulation, this is a crucial practice. Okay, that enough from me. You can do after that. Okay, thank you.
Hello, my name is Emmanuel Tamarampao. My matrix number is 2019407024. Today I would like to propose for the building air conditioning system is variable air volume system. What is variable air volume? Variable air volume is a type of heating, ventilating, or air conditioning HVAC system. Unlike constant air volume CAV system, which supply a constant airflow at a variable temperature, VAV system vary the airflow at a constant temperature. How does VAV system work? Let's break down an example of how a VAV system works, such as an air handling unit AHU pushes air into the duct system at roughly 12 Celsius for cooling. The air temperature stays constant in the system, moving through the ductwork at each zone or room of the building. The air eventually goes to the end of each line where it passes through a VAV box. Typically, a VAV box consists of a simple part, the damper, the actuator, and perhaps a coil of heating and cooling via electric or water pump. As the air passes through these boxes, the actuator modulates the damper position, which allows different amount of airflow into the zone. Each VAV box modulates according to the needs of individual zone, meaning it can easily accommodate high demand in one area and low in another, maintaining comfort for everyone. Additionally, if a damper closes completely, the added system pressure allows the AHU fans to slow down, reducing energy use. Or using a bypass damper in the middle of the system, increased pressure could trigger the damper to upon relieving system strain into additional duct or an exterior vent. And the advantage of VAV system is it was more precise temperature control, and the advantage of VAV system is it was more precise temperature control and reduced compressor wear, and it also lower energy consumption by system fans and less fan noise, and additional it has passive dehumidification. That's all. Thank you.